For the Unit 8 review, the first page is just a review of Pythagorean theorem. So on number 1, this is your A, your B, and your C is always across from the right angle. And so if your Pythagorean theorem is a squared plus b squared equals c squared, go ahead and plug these three numbers in. So if we calculate this, we would get 36 plus x squared equals 196. If I subtract 36, I get 160. And if I take the square root of both sides, it will give me with a decimal, and it does say round to the nearest tenth. So this gives me 12.64. So I would round to 12.6. In number 2, again, we got our A, our B, and our C is across from the right angle. Usually your A is your smallest number, B is your middle number, and C is always the largest number, always across from the right angle. A and B doesn't really matter. You could switch those up if you need to. But if I plug it into the formula, I get 16 squared plus 20 squared equals x squared. And then this would give me 256 plus 400. And if I add that together, we get 656. To get the x by itself, I square root both sides. And I get the number 25.61. Again, I have to round to the nearest tenth, so I would get 25.6. In number 3, the diagram shows how an electrical pole was broken. So here's the electrical pole. Okay, it was broken. What was the original height of the pole to the nearest edge? So I need to know what this plus this is. So first, obviously it formed a right triangle. And so I need to find this length. So that is my C because it is across from the right angle. Okay? So this is A, this is B, that is C. So step 1 is to use Pythagorean theorem to find C. And so I would have 20 squared plus 48 squared equals c squared. And when I calculate this, I obviously have some larger numbers, so 400 and 2304. Add like terms, I get 2704. And then I would square root both sides and get 52. C is 52. So step 2 is I would have to add this part of the pole, which is 48, add this part of the pole, which is 52, and that gives me a total of 100 inches. In number 4, you have to determine if it is a right, acute, obtuse triangle or not a triangle at all. So first we have to determine if it's a triangle. You have to add the two smallest sides and see if it is greater than 7. If it's greater than 7, then it is one of these triangles. So 3 plus 5 is 8. Is 8 greater than 7? Yes. So then what you do is you have to write it in the form c squared and then a squared plus b squared. And I don't put equals here because I don't know. It could be greater, less than, or equal. So C is 7 because that's your largest side. A is your smallest, and then B is the middle one. So I have 49, 9, and 25. And 9 and 25 make 34. So I need to know, is 49 less than, greater than, or equal to 34? Well, it is greater than. Okay, greater is obtuse. So greater is obtuse, less than is acute, and right is equal to. Okay, so let's try again. Part B. The two smallest sides we add together, that gives me 7. 7 is greater than 5. Okay, so that means that it is a triangle. That's true. So now I take the biggest length, which is 5, square it, and then the sum of 3 squared and 4 squared. So this gives me 25, and 9 and 16. If I add these together, we get 25. Is this equal to, greater than, or less than 25? Well, it's equal to, it's right. Okay, so equal is right. Okay, then, again, we're going to add the two smallest sides. So 9 and 14 would become 23. And 23 is greater than 16, so this is a triangle. The biggest side, so C, is first. And then the sum of A squared and B squared. So that would be 256, 81, and 196. And if I add those together, we get 277. All right, so 256 is less than 277. So that would be acute.